Yeah, thanks everybody for coming to our presentation on NoOps and data integrity. We hope that by the end that fancy title makes a little bit of sense. A couple of things though, I do want to have a disclaimer for you all just in case if you're looking for a technical deep dive into building DevOps systems and so on. You probably aren't going to get that here. This is more of a conceptual overview of automating DevOps processes and some of the important considerations when doing that. So if you really wanted to watch people drop some code and build some containers and things like that, you might go to another session. Otherwise, please feel welcome to stay and bear with us. At its core, the very basic element of this presentation today is it's really about automation and platform as a service. Now, we both work for a platform as a service company, so this isn't in any way meant to be a particular endorsement of our company, but on the conceptual level, we're all doing the same thing, whether we're implementing it differently and using some different tools and things like that. But we still come from the background of really sort of embracing this process of automation. We're adding some of the DevOps principles to DevOps itself, so building DevOps tools that work, and hopefully that's what we want to explain, and hopefully that'll make sense by the end of all this. So before we go too far though, I know some people here, I don't know everybody here, but quick show of hands, how many people here would you consider yourselves to be developers? Who's actually writing code?
Right now?
Yeah, well, great. So, just you two guys didn't raise your hands, correct?
Yes.
Would you mind sharing what do you do in this space?
I'm a business analyst.
Okay. For a Drupal, like, what's your involvement specifically in Drupal?
Yeah, we work with Drupal.
Okay. Cool.
Small Drupal shop. I do all kinds of different things because we're really small.
All right. And would you consider yourself a developer? So you came in last, but
yeah, but probably more strongly a site builder.
okay. Cool. So I think for a lot of you, this first anecdote might make sense. Right? So this is the general principle. If you want to, yeah, go ahead.
Let me know when to change slides.
Yeah, click. All right. So this is just, from April 2017, global internet use and penetration. The purpose of showing you this slide and the sheer numbers of people and people accessing the internet and things like that is actually, I want to actually create an anecdotal association for you, something that we can tie back to towards the end. So if you consider, like, for these numbers and this many people, the question I'd have is, for the overwhelming majority of these people, the experience of accessing the internet happens without any of them ever needing to know anything about the protocols required to run and access a network, coding software, setting up servers, etc. Right? I mean, can you imagine how long it would take to actually get this sort of critical mass of users if people had to understand things like TCP/IP? Or if we want to make it even easier than that, for people to tell you what TCP/IP even means, right? So the technologies and the separation that goes into creating systems for users versus people that are building those systems, there's a significant shift in the mindset of the way that you approach either being a user or being a developer on that. So that brings us to the next slide, kind of.
Is that this one?
Yeah. Okay, so as I said, hopefully by the end of this session, we've been able to clarify more about behind the title, DevOps and data integrity. But in its simplest form, what we really want to accomplish is to demonstrate the advantage of automating DevOps away. And before we can do that, we don't want to get too far ahead of ourselves. We don't even want to think about DevOps at the moment. First, let's go back to the story about people accessing the internet, accessing websites, and let's think about websites in layers.
Right. So when Aaron was sort of explaining the seeds of the idea of this talk,
and I was trying to get my head around the seeds of the idea of this talk, what it really kind of boiled down to for me is the concepts of, interface versus implementation. And so that last slide with the stats about how many people are online and the discussion about needing to know what HTTP is or TCP or any of the underlying sort of nuts and bolts as far as how a user gets online and interacts with the thing they're trying to interact with. You've got the interface, which is what people are trying to do and what they're trying to get done, and you've got the implementation, which is the nuts and bolts, the underlying sort of structure of all that. And so we have sort of kind of drawn up this matrix here of functional and non-functional parts, or application versus implementation. And so, thinking about it in sort of this way, the functional aspects of an application would be like, what is it you're trying to get done? Like, why are your users here? What is this thing that you're trying to build? How does it work? Not necessarily how it's built, but how does it work? What does it do? You've got an e-commerce site and it's going to charge customers, and maybe it's a site like Etsy or something like that, where it's a community-oriented site. So you're going to want to send out alerts when somebody buys something from somebody so they can ship it out. You might want to have a forum for allowing your users to talk to each other. These are like the why your people are here at your application. As far as the functional implementation of that, this is where you kind of get into the fun stuff for the site builders and the developers of us. Like, what data structures are you going to use to bring it like specifically into Drupal land? What fields are you going to put on these nodes? What are the different types of nodes you're going to have, or the different pieces of content you're going to have? Up on a more of a UI level, what color menu buttons are you going to choose? What fonts are you going to use? These are like the sort of the functional implementation of how you're going to get these things done. Over here in the non-functional access, these are like the things that like you and your users aren't really going to think about these things. These are like, what are you trying to get done here? You want a graphical user interface, presumably, if you're building a web app. Like the thing that people come to in a browser is your GUI. You want it to be easy to use. These are sort of like just the concepts that you want to bring across in your app. And then down here, this is the really nuts and bolts stuff here. Nobody really wants to think about how to get the bits onto disk, that your users are reading and writing to your application all day. Nobody wants to think about data corruption or making sure that data is consistent across, not just your production environment, but say your different development environments. These are the real nuts and the bolts that, that are maybe fun to think about on a conceptual level, and for some people as a career path. But for most of us that are building applications on a day-to-day basis, just are things that we would rather sort of farm out to somebody else or to another service to take care of. And so that's what we're talking about as far as the functional and non-functional aspects of these two, the interface versus the implementation.
Okay, how many people are familiar with all of this? Not too many? So? You've seen it before? Ish? Okay, cool. That's
if you work for a platform as a service company, you probably see this graphic a lot.
Yeah. So I want to skip to the next slide, but just before I do, real quick, basically, like, DevOps was really kind of birthed right around here, right? Like, sure, there were some DevOps practices happening here, but that generally used to be system administration, right? And that's sort of where DevOps has gone with the advent of cloud and different cloud offerings. So just keep that in mind. I'm still going to talk about this a little bit more, but I like the next slide better. This one always makes it really easy for people that aren't familiar with that. This is the as-a-service model, and it's really great for the on-prem versus infrastructure as a service, platform as a service, and software as a service. So this is back in the day. Some people here, maybe everybody here, at least I know at least some people here have the experience of when they first started creating web applications, it was just, they had their own server probably running in the closet, or there was a company server in the, pantry.
The closet.
In another closet where maybe the food was kept and, somewhere out of the way. And you had to do everything, right? You had to set up all of the environments. You had to have your production environment. You had to...
Should I go back to this one?
If you want.
I'll stay with pizza.
Yeah. And this was, you could either be a web developer and a system administrator, but as you know, I think data would show, people would tend to go one way or the other. You either became a systems engineer or developer, because this is an entirely different skill set, right? Well, as part of that skill set started going away, do you guys prefer the actual computer model, or is the pizza one fun? Yeah. So as some of this stuff started actually going away and being managed outside the service, then you didn't need to have the same level of expertise, but you needed to have a new level of expertise, right? A new thing. So if you bear with me, I try not to read directly from slides, but the definition of DevOps from Wikipedia: DevOps is a clipped compound of development and operations, is a software engineering culture and practice that aims at unifying software development and software operations. The main characteristic of DevOps movement is to strongly advocate automation and monitoring at all steps of software construction, from integration, testing, releasing, to deployment and infrastructure management. DevOps aims at shorter development cycles, increased development frequency, more dependable releases, in close alignment with business objectives. Great. That's a nice big mouthful, but really what DevOps is about breaking down the information silos that existed in IT teams prior to these models, right? Your system admins and your developers, and trying to treat your infrastructure as code, right? So that the developers could start to have more of the engineering skills, and then the system admins could start being more on the developer side. Trying to blend these two together. The thing is, DevOps, it's not really working out as it was intended, right? DevOps, just like system administration before it, has become its own unique and complex set of skills with an ever-growing set of tools. Now, yeah, for a lot of people, it's fun, right? That's, at the end of the day, it's a fun thing to be able to go in and create Docker makefiles and start playing with all these different pieces of the system that have only really been enabled, again, by sort of the more and more granular approach to infrastructure with the cloud models, right? Going from actual dedicated machines to virtual machines to containers, but they're all just essentially, it's just getting smaller, but it was still doing the same thing as before. But now when you get into these smaller pieces, now you have to have the microservices to make them all work. Not that different from what you were doing before on the system admin side. So, yeah, so generally it's fun for some folks.
Thank you.
But it's starting to be shown that the time spent orchestrating and configuring VMs, containers, etc., is just lost time on development. So, and just go ahead and click through. With an ever-growing set of tools, this is
Nice.
yeah.
This is so enterprising. God, are you serious? When does it end?
That's last. Oh,
Okay.
Come on, man.
All right, we'll just leave it there.
Put a lot of time into those automations.
Yeah, I know.
So if you don't believe me, I mean, yeah, this is just a small, like, this is just literally like the first, well, other than Lando, that's not really a DevOps tool. I threw that in here because I thought I might have a Lando troll in the crowd, so I was just going to, but he didn't show up. Because actually Lando's more of this automated process like we're talking about. But the rest of these, they're all great, but that's a really small list. You know, you just Google DevOps tools and all of a sudden you're expected to learn how to use each and one of these and make them communicate and work together. So yeah, remind me again, where were you supposed to do the development and where are you supposed to write code? So I think, let's see. I think besides the time required to learn to run all of these systems efficiently, there's another really major issue besides just knowing how to use these systems and run them. And the major limiting factor is system integrity. Click again.
No, there's more.
Yeah. So, your system integrity. First you have to learn the tools, then you have to know how to make them work, and then you have to worry about the integrity of the system. So, the data used and maintained by the system, if we break this up into different parts of integrity, we start with data integrity. Data integrity is just the data used and maintained by the system are complete, correct, and free of contradictions. Right? So how do you ensure that your data stays complete and consistent? Right? The next is behavioral integrity. And this is less about your data and the environments that you're working in. So how many people have experience creating a production environment and a staging environment from scratch on a Linux box? Yeah? Has your code always moved effortlessly between those environments? No? You're the only person who said no. Everybody else, yeah, you're
perfect.
yeah. So that's the behavioral integrity of the system, right? And this gets even more complex when you move away from centralized systems, which is where servers went to VMs and you're still doing everything more or less centralized, to distributed systems, where you're breaking out the database over here and you're breaking out the runtimes over here and you're putting in your research indexing over here. You have all these different pieces and you can distribute those out. So now you take that one level further and you put those all into containers, and you still want to make sure that your data is intact, which is just one of those skills that you picked up while you were playing with any number of those DevOps tools, and that each of those environments that you're building and working in are also intact so that they can both work together. And then security. Oh, sorry, I didn't give the definition of behavioral integrity. The system behaves as intended and is free of logical errors. Very simple, right? But again, the point being that I asked, is that the case? How often is that the case when you're spinning all of these things up and you're distributing these out? And then the security is just the system is able to restrict access to its data and functionality to authorized users only. So history shows that actually most software failures, such as loss of data, illogical behavior, unauthorized access, are the result of violated system integrity. One of those breaks down for the system. Now, these aren't the only elements, but this is a key element and a key concept. And I think that from the DevOps world, these are the things that make, when you can manage those aspects of the system appropriately, that's what enables the concepts of continuous integration and continuous delivery, right? You have to get these boxes checked before you can actually start working on CI/CD. So that brings us back to this model. And to be honest, I forget why I put it there. So
Back to pizza?
back to pizza. All right, so the general idea, this is starting from the very, very old school. Then DevOps kind of came into play here. And then our argument is that the next progression to actually improve everything is automation. And platform as a service at its core is just simply the automation of DevOps principles. It's abstracting away all that work from those tools that you have to learn, and although it might be fun and it might be cool, it's taken away your need to be Kubernetes experts and Docker experts and Jenkins experts and Circle CI or any of these other things. You can just now essentially become much like the web users that we talked about at the very beginning. You can just become a user of a system that you don't have to know all of the protocols and implementation factors that are happening behind the scenes to take advantage of the technology in a much more efficient and effective kind of way.
Thanks.
So, not yet. You look like you're about to breathe. So, why platform as a service? As I said, PaaS at its very core is an automation of DevOps, making DevOps into limited ops, or on really good system, no ops. So there's the first part of the title. We already covered the data integrity, so hopefully it's all covered now. A well-constructed PaaS manages not only the integrity of the system for you, but the complexity as well. And at its core, it's easily and essentially just software doing all of the DevOps work for you. It's just another piece of software that you don't need to know what's happening on the back end to utilize that and make your jobs and lives better. So if you consider it in layers, just like we did before for the website users, And we approach web development as a user of a system rather than the creator and maintainer of all systems related to developing and deploying code that allows you to focus on what really matters. And with that, John, would you?
Yeah, sure. So we're back to this matrix now, the functional and non-functional aspects of both, well, the application versus the implementation. The application, like I said at the beginning of this talk, I think of more as the interface, What are the things that you are trying to do in your job? What is it, the things that you are trying to get done? These are questions you kind of have to ask up front in that part. How are you going to manage code? Are you going to FTP it to the server? Are you going to commit it to Git and push it somewhere and then have stuff happen in order for it to be deployed? How are you going to deploy new features? Is it going to be a process of FTPing code somewhere? Or having, maybe you push it to Git and have Jenkins create some sort of build artifact and then push that out into your development environments. How are you going to manage those development environments? Are you going to give each user their own virtual machine in order to have them bang on whatever it is they're banging on that particular sprint? Or are you going to create something a little bit fancier where maybe each feature that a set of developers are going to be working on will have its own development environment somehow? The implementation aspects of, fucking like, this is where you get into this gets a little closer to the nuts and the bolts as far as, how are you going to save the data? Nowadays, as he talked about earlier, these granules that we had to think of as developers and developers who are engaging in DevOps processes just keep getting smaller and smaller and smaller. So in the beginning, we had a metal server that we would deploy our code onto, and eventually we started using shared servers. Probably at some point, virtual machines came along, and with that, things like Amazon Web Services and Linode, most of the server, probably services that a lot of us have used. And then it gets broken down into containers. Well, okay, containers are a great thing for a number of reasons, but they also introduce a whole lot more complexity. So how are you going to divide up that unit of work? If you're working on a Drupal site and you want to deploy into a containerized infrastructure, are you going to just throw everything, Drupal, the database, the Solr server, are you going to throw that all into one container and deploy that? Or are you going to split everything up into a bunch of different containers, somehow network them together? How are you going to specify what it is you are actually trying to do? And this is getting more into even further into container orchestration. There's a variety of different container orchestration platforms out there, like Docker Compose, Kubernetes, etc. They each have their own requirements as far as telling them what to build at the end of the day. Spontaneous development environments, maybe like I was saying earlier, each feature or Git branch that you're working on will have its own development environment. Like, wouldn't that be amazing? Without having to actually create a VM, install the software on there, create the Jenkins job to watch this Git branch and push it over to that VM, every single time you want to work on a new feature. And the non-functional aspects of all of these things actually stay the exact same, these are the things you don't really want to think about. The GUI, of course, it should be easy to use. This is where this is where the rubber really meets the road as far as, how the thing gets built, the data storage, data integrity, the attack vectors of this thing. These are the things you don't want to have to think about, So that's why, in this day and age, a lot of people choose to go with the platform as a service. DevOps is still a concept of allowing operations and development to work together to increase your deployment cycles and features that you're trying to get out to your users. But it introduces so much complexity that it actually makes it harder to fulfill that promise. And so farming some of those things out, like the electricity in the oven and the gas for your actual for your pizza oven, that's where a platform as a service can come in and sort of abstract some of the need to think about every single thing in your system. And so that's why PaaS.
So at the end, to wrap things up, first of all, I think that the proper title was NoOps and system integrity rather than data integrity, because that's breaking the integrity up into those three different sections. Those are the things that you have to worry about to make a successful DevOps system. And we're not up here trying to say that you shouldn't do DevOps or things like that. Rather, the argument is DevOps is just it's the progression of systems engineering and systems administration. And now it has its own complexities and tool sets and expertise that's required to fully do it. And if you're just one of those people that loves doing it, then great, I mean, that's cool. I mean, I spent some time learning how to write YAML files myself, and I don't do anything. I'm a sales guy. I just thought it was cool to be able to play with virtualization and so on. But if you're doing all that, but you also code for a living, are you making your hourly rate? Are you billing out? What's it costing you as a developer to learn this other skill set? If you do it because you like it, great. But if it's cutting into your bottom line and you know that there's another solution out there, that's where the argument comes into play of NoOps and system integrity. So keep making great websites. That's all we have to talk about, but we're here to answer questions. Sorry, it was a bit short. This was our first time through. I actually just finished writing these slides about an hour ago. Any questions? All right. Yeah.
What are your feelings about why not? I mean, you mentioned them a little bit at the end, but for me, it's sort of, I like to go out to eat, using the pizza analogy, but I can't go out to eat every night. It's more expensive in some ways, anyway. And then, you sort of miss out on some of those experiences of learning how to be a better cook. I think there's some innovation that you lose when, everyone starts using the same sort of platforms and they're not sort of doing some of these innovations in there. And so how do you, do you draw the line where you balance out which one you think is preferable in a given situation?
I mean, for me, I would answer that as the true cost of ownership, right? I'd give the true cost of ownership answer there, and that's what is it costing you from an opportunistic standpoint? What is the opportunity cost? And sometimes that opportunity cost is directly your bottom line, right? Where is your time better spent, basically? And while I wouldn't disagree at all, I think, the better you are at understanding all that other stuff is probably going to make you a more innovative and competent developer and all well-rounded. And in general, I think people in this industry tend to be the type of people that also always want to level up, right? You want to be better, and I think that's absolutely one of the ways to do it. But what is the opportunity cost? What is the trade-off? If you're there to make money, if you're running a team and you want to see your efficiencies maximized, and you want to cut into your bottom line from both directions, not only because you can have rapid prototyping and shorter iteration cycles, but it's also costing you less because you don't have to pay people billable hours to configure infrastructure and microservices. You're saving on both ends. So what is the opportunity cost and what are you doing it for? Right? If you're doing it to level up and to be an expert, and that's what your calling in this industry is, then keep doing it. But I mean, even using pizza as an example, most people buy pizza. They don't necessarily make it at home, but those that do become better cooks and often like their own better than what they can buy. So,
yeah, the developer answer that I would give you is tagging on to exactly that. You probably, if you might have grandma's pizza crust recipe, like my mother-in-law makes an amazing pizza crust, and they never buy pizza because hers is amazing. So if you are able to roll precisely the solution that you need for precisely your business, that might be one reason why.
I would just counter on that real quick and say, if you're selling that as a service to somebody else,
that's exactly what I was going to say.
That's great. Then you're making money doing that. But if you're doing it on your own, I think that's
if your job is as a pizza shop, you're not going to be buying pizzas from another pizza shop and then reselling them to others. You're going to make your own pizza. There's also, and this is a case with any platform as a service, you're going to run into edge cases, that the platform as a service probably won't be able to support. There are plenty of use cases every day that people come up with that we just can't support yet because we're building this thing over here, building that thing over there, and at the end of the day, everybody's application, you could take 12 Drupal applications and they would all have unique things about them, even though 95% of the things might be the same. And so it's when you start running into those edge cases if those edge cases are significant enough to you and your application, your business, that's when you might think about rolling your own.
I think to put it in a Drupal context, you got the Drupal learning curve, which is you can become a site builder, you start to understand some of the concepts, and you aren't quite at the best practices and stuff. You're kind of learning how to do things, and then you start wanting to build better sites. You start to learn the programming, and you get to the point where no developer would ever want to take your site from you because your stuff is so crappy because you don't know enough to actually do things the right way. And then you get to the standards level where you start understanding the best practices. And then you're learning the next stage where you're really understanding how to do caching and other things to deal with Drupal. And then you're at the Grandmaster status where you understand the front end, the back end, you're able to do all those concepts. And it's kind of similar to here with that. If you just want to set up a development environment, you're not worried about security, you're not worried about best practices, you're worried about just what works for you, and so you have that level of understanding. But when you're taking it to a production environment, do you want to be practicing that stuff where you really need an expertise, or your site's going to get hacked, or whatever. So it's kind of like how much effort do you want to put into learning it compared to what level do you actually want to accomplish. Some solutions go all the way to your desktop and help you with the dev environment. Other solutions are just, here's production and how we're going to help you out with production. So it's kind of different stages as far as what is your expertise, what do you want to learn. If you're kind of jack of all trades, master of some, maybe you want to learn enough to get to a certain level of doing things. Maybe you want to run your own QA environment, but production, maybe you're better off leaving it to somebody else.
Yeah, I'm definitely conflicted because I think there are moments where, as a team leader, you want to build a team that has capabilities of doing some of these things, and when the edge case comes around, they can sort of do it right away. Mm-hmm. There are other instances where, like if there's a really high-profile website or something like that, millions of users, I don't want people hacking away at it, like you're saying. So, in that case, it's probably more valuable to me to go with platform as a service.
And how big is
the risk
your
is
team?
offloaded.
How big is your team? And even look at front-end development. We've had discussions about front-end and back-end development, and can the same developer do both and stuff? And it's like front-end, just the appearance and stuff changes so often. There's so many things that come up, new technologies that you need to get involved in and stuff. And it's the same thing with security. So much is happening with security and performance and things like that. Can you keep up? If you're a small, 4-person shop, can you really afford somebody to understand that level? Or, if you're a 20-person shop, then yeah, you can probably have somebody that's doing it all the time. But you mentioned a really busy website and maybe have somebody do it then. Well, that person with the expertise, is he going to get enough usage and enough knowledge to be able to do it and keep track of all the changes and what's happening?
And are you sure he's not going to get hired off with all those skills?
And leave you with this legacy system.
Yeah.
Any other questions? No?
Isn't there a certain risk of vendor lock-in? Because, you work with a platform as a service, and they abstract how you interface with all of your smaller services like MySQL and Solar. So you're learning how to interface with those. The platform is through a YAML file. It's a little bit different for Aqua and Pantheon. And then you run into these edge cases where, say you need a terabyte of storage on a server. The platform doesn't really like that, so you hook it up to AWS, and now you have your infrastructure, and you're hooking it up to a platform, and you're going to run into issues there eventually. So is it really worth it to work with a platform instead of just automating it yourself?
Well, it just comes back to the same question, same answer, right? So, of course, platform as a service is in no way meant to be panacea to solve all the issues and cover all of the different aspects. So when you say, is it worth it to build it yourself? I don't know. What is the opportunity cost? If I'm the one that's managing the team and I have the contract and I have the digital services division and I have to think about what is the critical path to get there? First is okay, who on my team already knows how to do this? And then if it's, say you have somebody, well, how well do they really know how, right? When they know how to do that, does that mean that they play with VMs in their spare time, or have they gone through AWS certification and training? Have they done all of that work? Like, where are they at in that level? And if they're not already top notch, then okay, so what's it going to take to get them there? Realistically, how many hours? Is it going to be 40 hours of constant training that I'm paying them to learn the system? Is it going to be 100 hours? So, I'm always thinking of it in a dollars and cents perspective. And that's probably why I'm in sales and not in engineering, because for me, ultimately, that's what it is. That's what the money spent doing that is money that is not spent building the project. So what is that investment? And then what are your assurances at the end that your one person that you invested all this time into becoming the expert is able to build a better system than something that's been built by a team of experts and had millions of dollars and thousands of hours and work years put into it? What are the chances? Sure, covering that use case, you might be able to figure out all of those elements and security and all that. But what did it take to get you there? And then what if you leave? And then they're left with that system. So there are use cases where it's better to do it yourself, but they're less and less. And we actually deal with things all the time. We're getting into bigger opportunities with, like, let's just say, universities, right? And we've been with a couple of universities that are doing like 1,000+ sites, right? And they start off with, oh, we're going to use Docker. We're going to do it ourselves. Okay, so literally 12 months later, when we run into them at the next event, hey, how's the Docker project coming along? Yeah, we need to talk to you guys. Right? Because building the system at scale is, like I said, it's fun to play with, but actually doing that just takes a lot of time and a lot of effort. And in something that's like this is a product that is the productization of thousands of hours and millions of dollars from a team of experts. 9 times out of 10, this is probably going to be the better approach.
That 1 time out of 10 would be your edge, like if you've got a database that's a terabyte, like.
Which also, we like terabyte databases, but they're really expensive, so.
Yeah, it's not that we can't handle it, it's just it's a little prohibitive.
Images.
Right. Well, I mean, geez, is storing that, is that really the right solution to be using then,
Well,
like images specifically, throw them up on S3 or something like that.
Upload high quality PSDs so they can customize them.
I mean, I would say
offload them S3.
Yeah,
Yeah.
that's why cloud storage object stores. That's why those things were invented, for exactly that.
Cool. Thanks for the question. Anybody else? All right. Well, thank you all for coming. I hope that this was interesting. And
Better.
we have a table downstairs as well. We have a paper airplane game that we like to do at events.
Yeah.
You can win a Lego 5. 5 rocket. So stop by and see us, say hello. We're also sponsoring the party tomorrow night, so beers on us. Come on out and take a chance and say hello. Thank you all for coming.
And thanks for the question.